Welcome to Homework Lib.
So over here we have two different reactions that are going to change the rate with respect to the initial concentration of one of the compounds. So we have two different concentrations, E and F, and we want to calculate what is going to be, first of all, the order of the reaction, and with that, we're going to be able to do the calculation of all of the different entries that we have here. So for the reaction of E, we're going to begin with rate for the reaction E. This is going to be equal to a rate constant times the concentration of E. What we know in this case is that if we divide the instantaneous rate of two different experiments, what we're going to get is rate, let's call it E1 divided by rate of E2. This is going to be equal to K times the concentration of E elevated to the order of the reaction of E in the experiment 1 divided by K times the concentration of E, and the second experiment elevated to the order of the reaction. So the ratio of the rates, let's call it rate 1 and rate 2, is going to be equal to concentration of E on the first experiment divided by concentration of E on the second experiment, all of this elevated to the order with respect to E. Here I'm just going to explain it for E, and then we're going to do the same thing for F, and we're going to see what happens. So in this case, for E, the rate goes from 2.0 in trial 1 to 1.6 in trial 2. And the corresponding concentration is 1.0 and 0.8 elevated to the E. So this gives us 1.25 is equal to 1.25 elevated to the E. So it seems straightforward. The order with respect to E is equal to 1. So we are going to employ the first order rate equations. For first order, we're going to get that the rate is equal to K times the concentration of E. So we just need to find the value for K. We can employ either experiment to get the value. So the value for K would be the instantaneous rate. Let me call this rate constant for E, for the experimental E. It would be equal to the instantaneous rate divided by the concentration of E. Let's pick the first experiment because we have the value of 2.0 molar second to the -1 and the concentration of 1.0 molar. This is going to give us a rate constant of 2 seconds to the -1. Thus, the entries are going to be simply multiplying 2 times the value. So 1.2, 0.8, and 0.4. Now let's look at the other side for rate equation 2. On experiment F, we're going to do the same procedure. Rate 1 divided by rate 2 is going to be equal to concentration of F in 1 divided by concentration of F in 2, elevated to the order with respect to F. In this case, this is going to be in order 1.0 divided by 0.8 equal to 2 divided by 1.28, and the concentrations need to be elevated to the F. From here, we get 1.5625 is going to be equal to 1.25 to the F. To get the value for the rate, in this case it is not quite trivial. We can try and take 1.25 squared, and you're going to find that F is equal to 2. But for a more general case, we're going to take the logarithm of 1.25 to the F. This is going to be equal to 1.5625. Sorry, to the logarithm of 1.5625. (1.5625) By loss of logarithm, this is going to be order with respect to f times the logarithm of 1.25 is equal to logarithm of 1.5625. F would be equal to logarithm of 1.5625 divided by the logarithm of 1.25. This is going to be equal to 2. So the order with respect to f is going to be equal to 2. Thus, our reaction rate, in this case, rate for, for the reaction involving f, is going to be equal to a rate constant for this compound f times the concentration of f squared. We can get the value for the constant of f, taking one of the instantaneous rates divided by the concentration of f squared, and we're going to take for simplicity the first experiment. In this case, the rate is equal to 2, as you can see from the first entry on our table. Here, rate is equal to 2, concentration is equal to 1. So our rate constant is going to be 2 over 1 squared. The units are going to be molar second to the minus 1 divided by molar squared. This is going to give us molar to the minus 1, second to the minus 1, and the value is going to be 2. So now, what we need to do is to get the instantaneous rate. For any of the entries, we're going to get 2 molar to the minus 1, second to the minus 1, multiplied by the concentration of F on that experiment squared. So, plugging in those values, we get, over here it would be 0.72, 0.32, and finally 0.08. So that would be all. Just as a small recap, remember that the first thing that we need to do is find the order of the reaction with respect of the reagent. For E, the order was equal to 1. For F, the order was equal to 2. Calculate the value for the rate constant. In this case, for the first one is 2 seconds to the minus 1. For the second one, is going to be 2 molar to the minus 1, second to the minus 1. And just employ the order of the reaction to multiply the concentrations to the appropriate exponential. So that would be all. Thank you very much and have a good one.